Welcome back to the Drop-Tine podcast, listeners. This one is going to blow your minds. And I know I've said that before, and my goal today is to change how you look at insects. Pest insects, I don't personally like that terminology, but hey, a lot of people use it. So I want you to look at pest insects in a different light after this conversation. I'm going to go ahead and introduce my guest, the great Dr. Thomas Dykstra from Gainesville, Florida. Dr. Dykstra, you with us?
I am with you, Jason. I'm still recovering from that introduction and checking to make sure I'm on the right podcast. So, we're good to go when you're good to go.
Oh, man. How many podcasts have you been on with wildlifers, deer hunting, deer managers, wildlife biologists?
Oh, man, it is too many to count. You're the first.
I kind of figured that.
Yeah.
Why would a wildlife biologist want to be talking to what do you consider yourself, more of a private researcher?
Yeah, I think that would probably maybe? It would, because, I wanted to be a normal guy, and I was a normal guy. I want you to know, and all your listeners to know, I used to be a normal guy, the guy who, wasn't, making any reverberations. I wasn't creating any waves. I was just normal. And then, things changed. So I did want to go into academia. That I just thought, I can speak, therefore I should get up in academia and teach. And then a lot of that changed, especially for the PhD, which was back in the 90s. And then because things went off on this different path, I've been on this different path. I haven't jumped off this different path. So therefore, I am now not in academia. I'm not associated with the USDA, which is where a lot of the classic entomologists are found. And I am an independent scientist. I call myself more of a scientist sometimes because a lot of people, they associate me with entomology, and they should, because I have all 3 degrees are in entomology. So on paper, that's what it looks like, and that's what everyone understands, and I accept that. And then I've also got this agricultural background where I spend a lot of time talking to individuals and farmers about agriculture and speaking at conferences. And then I have another field, the bioelectromagnetics, which started with the PhD, and therefore I've also done consulting when it comes to bioelectromagnetics, as far as electromagnetic fields, how they affect organisms, and all that weird stuff. So based upon that quick introduction, you can see how far off the normal path I have come.
Yeah. So we were just kind of laughing about this. The electromagnetics is something I would love to sit down and just geek out on, but I won't do that to my listeners right now.
Because we're going to lose all the listeners, yes.
Yeah. But I'm here to tell you that just as crazy as that sounds, the information that you have on insects eating plants, pest insects, why people have armyworms, or whatever pest you want to pick is absolutely mind-blowing. And I've been wanting to do this podcast now since at least 2018, and it's 2024 as we sit here. That's how long I've been wanting to do it, and I've kept articles and literature, etc. I will admit your scientific papers are pretty thick, and they're that. But this information is crazy, and there's a lot of stuff I want to go over. But first, I'm sort of intrigued by this idea that I don't want to say so I almost went down the same path. I wanted to get my master's, my PhD, and teach and do research. I wanted to have grad students so that I could use other people's money to investigate specific things that intrigued me with white-tailed deer, wild turkeys, quail, waterfowl, whatever. What happened? Why did you smarten up and get out of that?
I was forced into it. So kicking and screaming, I came out at the other end and realized that this was going to be my future, and if I wanted to go back, that I wasn't going to be able to. And that's how it happened. So I began the PhD. Things did not go as well as I had hoped after a few months. It ended. I was let go. I was fired, whatever word you want to use. And a few days later, I was picked up by Dr. Philip Callahan, and he was here in Gainesville. I'd known him for who knows, I don't know, maybe at least a year ahead of time. So we're relatively new friends. And so because of this, he took me on. I was still doing the same project that I did before. The project that I did was off the beaten path. We were taking a look at flea larvae of all things. And there seemed to be, and I put seemed in quotes, an electromagnetic component to what they were doing. And so when I was going off down this path, I was a little upset because I was a normal guy, and I wanted to stay a normal guy. I had a bachelor's degree in entomology, so that was relatively normal as far as entomologists go. I got a master's degree in entomology, still normal, haven't gone weird yet. And then the PhD happened, and I found out this behavioral effect that was going on that I could not explain. Thought there was a bioelectromagnetic component, decided to pursue it, and that is how it happened. So I got thrown into this because I wanted to be honest with myself, and I said, okay, I can either be honest with myself and go down the rabbit hole of bioelectromagnetics, which I did, or I can avoid that thing and just kind of stick with a classic chemical aspect and try not to get too weird so that I can continue to publish and get the research out. So that's how it all happened. So I got pulled into this. I then started to embrace it, and once you start to embrace that, a certain peace comes over you, because I wasn't peaceful before, because I realized I was moving away from my goal, but then a peace kind of overcame me when I realized that this was what I needed to do. This is the direction I needed to go. And a full year before I even graduated, I was contacted by a benefactor who said he wanted to continue this process. So he was helping me through the PhD. He said he wanted to help me through the process. He wanted to continue this process. He wanted to give me my own laboratory, and he would start things off. And I thought, wow. I mean, right now, I wouldn't go anywhere else right now, because essentially everything is being handed to me on a silver platter, even though I knew my reputation was going to be in the mud. And so now I had this, okay, it looks like I could be starting a new laboratory, but my reputation's in the mud. Do I want to continue going down this path? And I'm not sure if I do, but I became more and more sure over time, and that's how I started going down this path. And that's where the insects came in too, because this insect stuff is not something that I came up with. The insect stuff has, in regards to the plants, has been known for literally decades, and that is that insects will not attack healthy plants.
Oh,
however,
you're popping the cork already. You're popping the cork.
Yeah, I mean, it was just a question. It was just a question that was brought up. Everyone was kind of saying it, and so I was the dumb entomologist, and I was going to conferences, and people are asking me, what do you know about healthy and unhealthy plants, and insects don't attack them? And I'm kind of looking at them like, man, you're weird. Get away from me. And so this kind of continued for a little bit, but then I started asking myself this question, saying, look, I've got 3 degrees in entomology. I can either prove it or disprove it. So if I'm going to disprove it, I'm going to need to be able to have a good grasp of what is going on. And so when I hit the literature essentially being on the internet, all I got was the magic number of 12. And that is, if you're above a 12 bricks, you're fine, you're dandy, everything is good. If you're below 12 bricks, your plants are going to be in trouble, insects are going to attack it. And that was just one, I'm asking myself, like, what's bricks?
Yeah, right.
And then I'm asking, like, why is it the magic number of 12? So at 12.1, everything is hunky-dory, and 11.9, you're in trouble, and insects are attacking you right and left. This doesn't make sense. I've got to be able to figure out some of the details as to what is going on. And so this path was something that I had done for literally a decade in obscurity. I wasn't publishing. I wasn't doing a lot of research. I was taking a look at it. I was reading articles. I was finding out more and more that this was true, but I was kind of moving in an insect olfaction direction, which actually brought me back to the insects and bricks question. And so looking at insect olfaction, it was back in, I got the PhD in 1997. It was 5 years later, give or take. 2002, 2003, I was reading a book. It was like, the Bible of insect olfaction and trying to understand how they smell and how they detect
That's
pheromones.
an interesting read, huh?
It was a thick book. I don't even know how many pages it was. It must have been 500, 600 pages. And after getting through that book, and yeah, I have no life. Go ahead, make all the comments about nerds that you want. But I was really taken by this book. And at the end of it, you kind of shut the book, and I realized they don't know what they're doing. Mm-hmm. This is wrong. This current theory of insect olfaction is wrong. And so if it's wrong...
Hold that. I love that.
Oh, I got to hold a thought now, don't I?
Hold that insect olfaction being wrong. So I just want to make some comments and unpack a lot of some of what you just said. First of all, in my mind, you're an innovator. So I have the original podcast, and then I started the Innovators podcast. And I wanted to do less podcasts, but do high quality and find very unique, don't take this the wrong way, very, very unique guests, people who had something different. They innovated, right? They were early adopters. They were people that were related in some way to wildlife ecology, science, hunting, whatever. And you fit that mold exactly. And interestingly, and I've told you this before, you remind me a lot of Dr. Rick Haney, who is a good friend of mine and also a business partner of mine. And, in the way that you guys look at things. He's told me so many stories, and I remember him when he was a grad student and him saying a lot of the same things you were saying. That he was like, why, again, are we using these crazy extractants when it rains water? And all these just basic questions, that anybody would ask, not necessarily a PhD student, and nobody could answer the question. And then he started looking back through all the literature, and he found that the Russians... oh my gosh, they were doing this all along. Some Russian scientists were already doing this, and then it died, right? Somewhere around World War II, when all of a sudden we had all this, stuff to sell and make money. So that's all good stuff. I love that. Let's go down this path right here, right now, while we still have some listeners' attention. As I said, I want to change their mindset. We manage food plots, all right, Tom? So it's agriculture in a sense. Most of us learned how to manage these food plots or plantscapes for, specifically planted for wildlife. We learned from farmers like me. I learned from a conventional chemical industrial farmer, to the
classic chemical farming. I got it. Yeah,
perfect. I mean, he's the poster. But what I want people to understand, and you kind of, like I said, pop the cork a little bit. But one of my questions years ago, when I started looking at your work, and others have asked me, have you had Dykstra on the podcast yet? This guy's work is fascinating. The fact that a lot of it is, as you said, private and sort of under wraps is interesting to me, and the fact that you're an independent scientist. But as I started reading your work, I started thinking to myself, okay, are we really, or are the pest insects that we have in our food plots, are they really competitors and competing against me? This was the very first question, like you posed a question there. Are these things really competing against me to eat and chew down my food plots? Or are we really after two different goals? And can we work together in some way? And then I read your paper or some of your work, and I was like, oh my gosh, I'm after developing a diversity of healthy plants, a plantscape, if you will, grown in biologically robust soil where the microbiome is diverse and it's void of toxins. It's not disturbed with tillage constantly. And then you come out and you say, hey, insects really are picky eaters, and they prefer the shitty stuff. They want the crappy stuff that's either injured or dead or dying or malnourished or whatever. And I was like,
yeah, and there goes the family show right there. Yep,
exactly. Okay. There's my answer. This is crazy because we want the highly nutrient dense forages for deer. But yet you're saying to me, Tom is saying, hey, no. Insects actually want the dead and dying. In other words, these people who have armyworms all over their food plots, that's just a symptom of the problem, right? That is merely what you're looking at. So taking the insecticide, and many times preemptively they strike with insecticides or any side, and then when they find one, oh my gosh, that's the threshold. They spray again, And I heard your stuff, and it made sense. I had a hunch that, hey, maybe we've created this dysfunction with the very quote unquote tools we're using, like the sides. And here we are in this crazy loop of never getting out of it. So that's kind of what I want to talk about to start. And as you have said, if insects are eating we'll just call them food plot crops or ag crops, that's an indicator. It's a clue that you're not a very good food plotter or you're not a very good farmer. Is that? And I've told you don't remember. I said to you before this is an uncensored. You say whatever you want to say. Nobody's going to get angry or fire you anymore. And I know you.
Yeah, well, there's no way I'm going to insult farmers. A lot of the farmers do not know about what I'm talking about right now, and therefore they're simply acting through ignorance rather than malintent. If they were acting through malintent, in other words, I know it's wrong, I'm going to do it anyway, I want to poison this and poison that, I want to poison my family, I want to poison the entire world, then I'd say, okay, your intent, you have malintent, and you're not a nice person. But the farmers that I've run into are not aware of what is going on, and they simply just need to be a little more educated about how these plants are raised, because when you look about you, especially in nature, and especially when you're out hunting deer, Jason, you see plants. And these plants, for the most part, are not being attacked. That's because most of the plants on planet Earth are healthy enough not to be attacked by insects. So that's why when you go to the tropics, you see leaves and trees. This is why when you go to the Hawaiian Islands, you see things like leaves and trees and lots of grass. When you go to parts of the world that are essentially undisturbed, you see a lot of vegetation. This vegetation is mostly, not always, but mostly not being attacked by insects. It's also not being attacked by most disease, too, but it's healthy enough in order to grow, which has got to make you scratch your head thinking, how is this possible? Why is this not being attacked? Because we were always told in school that if you build it, they will come. If you put out the plants, they will attack it. And so therefore you have to defend your crops immediately. And I thought, well, who's defending everything else on the planet? Because right now it's only being kissed by the sun and rained on by God. That's it. And nutrients are somehow finding their way into the plant. They seem to be relatively healthy. They are being munched on by various vertebrates, but they're not being munched on by invertebrates. And that's why you have a vertebrate like you and I, you have vertebrates like deer. These are higher level organisms that want higher level plant health, and that's the type of plant that they want to eat. On the other hand, you have nature's garbage collectors, as it has been often termed, and these garbage collectors are the insects, and their job is to clean out plants that we should not be eating. And so that's why when we have crops, we can grow them. Most of the time, everything is fine. Other times, they're attacked mercilessly, and we again scratch our head trying to wonder out why. I've planted corn before. I never had a problem, but this year, I've got a major insect problem that's attacking my corn. What is going on? These are the questions that need to be asked. You've apparently asked yourself that question already, and you've been thinking about this now for, I guess, 6 years, because you mentioned 2018. And so part of me is wondering, why haven't we talked before? But I won't take it personally. The other part that I'm asking right now is how many other people have not asked that question before, too, where they haven't said, why is this plant not being eaten, and why is that plant being eaten?
Yeah, when you came out and started yelling from the rooftops that no insect will ever attack a healthy plant, that got the wheels spinning to me, and I said in my head, and I said, wait a minute, insects want unhealthy plants grown in some toxin-rich, if you will, biology-depleted medium. Sounds like farmer dirt to me. It sounds like all the neighbors around me who practice recreational tillage and dump the sides and pre-emerge and post-emerge and blah, 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 blah. And I thought, man, that's so great. These insects, all of them, are actually helping me remove the unhealthy, sick, and dying. And I've already told you this. I sat back and said, you ding-dong, that sounds a lot like predators, like terrestrial predators, right? That's how we are trained as biologists, that the wolves, the coyotes, whatever, the mesopredators in the middle. Yeah. Without the predators, you do not have the prey, and without the prey, you do not have the predators. So I guess...
we all know that the cheetah goes after the gazelle with the broken leg.
Exactly.
And so the healthy gazelles, they escape, but the one with the broken leg, gets caught by the cheetah, and we get that. We say, oh, well, that's nature. Well, apply that to everything, including the insects, and now everything starts to fall into place.
Yeah. So there's this big difference. I want you to go back and unpack this. All right, I'm going to say this 10 times, that no insect will ever attack a healthy plant, per Dr. Thomas Dykstra, not Jason Snavely, but I agree 100%. But there's this big difference, as you said, between in the digestive system between you've said mammalian. Let's just talk about these mammalian herbivores. I think it's funny. A lot of times when I use that word herbivore, people immediately think of a critter like a white-tailed deer, and I do too. But what about these invertebrate herbivores, right? So what you're saying is there's a difference if I go out and nibble on, I don't know, say a soybean leaf, and an insect nibbles on a soybean leaf, there's two totally different things going on in our systems.
We are digesting two very different things. You are correct. We are looking for a high-quality plant because this is what our digestive system, this is actually what incurs health in a human being. If you want a long life, living into your 80s, 90s, and beyond, then you need to be able to eat healthy. If you are not eating healthy, we often succumb to many of these chronic diseases, sometimes not so chronic diseases. Mm-hmm. Our body then collapses. It starts to get sick in various ways, and this is in no small part due to the food that we eat, because a lot of the food that we're eating is not healthy enough in order to sustain healthy life. Not sustain life, Jason.
Yeah, ultra-processed junk foods.
Yeah, a lot of this stuff is a little too processed. It's fine as snack food. We can get by eating the Doritos and some of the other snack foods, and we'll be okay. But if we're eating this food for 20 to 30 years nonstop, you know what is going to happen to the body. I mean, I don't think I have to tell any of the listeners, because they know instinctively what will happen to the body. And deer know that instinctively too. They will avoid unhealthy plants. They will only go after the healthy stuff because they want to be healthy, just like we want to be healthy. The insects are going after partially digested plants because that's all their digestive system can handle. Once you have really good, healthy proteins, they can't digest it. Deer are fine with it. Human beings are fine with it. The vertebrates do very well on good, healthy food. We've got the ability and the desire in order to eat healthy foods, and it's the opposite for the insects. They want the crap. They want to be able to eat that. They want something that is partially digested, and that means incomplete proteins, broken down proteins, broken leaves, broken stems, broken roots, broken down biochemically, broken down in some way that the insect is going to be able to easily digest it with its very simple digestive system, because that is what they are designed to do.
That's great stuff. So I want everyone to remember this, that there is that insects are not interested in attacking healthy plants. Do you know that to be true?
I know that to be true. Okay. I haven't seen any exceptions yet. But you often have individuals who have something to lose with this philosophy that is being spouted right now, and so for those who have something to lose, they will attack. Mm-hmm. Sometimes it will be an ad hominem attack. Sometimes it will just be various four-letter words. Other times they will attack in various other ways, but they usually don't attack scientifically, and so. For any listeners right now, we're having difficulty with this. I'm now going to tell you how you may attack me scientifically. Get a Brix refractometer, go out, start testing leaves, and disprove me. And then I will be disproven.
Okay, so you're jumping to Brix. You jumped to page 7. I'm on 5. So let's hold Brix.
That's okay. We can go back to 5.
Yeah, let's hold. I'm a slow reader. My kids laugh at me all the time. They're like, "You didn't read this yet? Hurry!" So we're going to go back to Brix, but before we go to Brix, I want to get back to this idea that because there's probably some people out there thinking to myself, okay, how do they know? How do these insects know that a plant is unhealthy? Other than obviously visual cues and how do they? We can do all kind of tests, et cetera. How do these insects? I mean, insects are stupid, right? They're some little, tiny little. They can't have a brain anything close to us. How are they doing this? One of my good friends, David Kleinschmidt's been on the podcast before. He's an agricultural consultant. I knew he would just be geeked out by the fact that you were coming on. He's like, ask him. Get to the way that they find these plants, and that's what he really wanted to hear about. So how do they just fly around looking for a plant that's yellow or purple or how does that work?
Yeah, I am so sorry about this because now you just asked a question where I have to go into electromagnetics.
Yes.
And so I just want the listeners to know right now that this is totally your fault.
Yeah.
We could have avoided this, but you wanted to go into this headstrong, so I thought, all right.
Rip the Band-Aid off right now. Rip it off.
Yeah, many insects, when they're flying high above, and I'm talking about locusts right now, when they are looking down, they will see things that you and I don't see. They will see the colors, the Roy G. Biv and the visible spectrum that we're all familiar with, but they're also going to see infrared. And infrared is given off differentially by different plants based upon their various stages of health. We know this already. We've got lots of satellite data where you can literally ask a satellite, get online, ask a satellite to take an infrared picture of your property or at least that area, and you will get an infrared photo and you will see different colors appear, even if, let's say, everybody's raising corn and everything that looks green on a visible shot from the satellite. As soon as you switch to infrared, things look very, very different, meaning the plants are not the same. And so visually, that is the first thing that they do. Once they're visually attracted, they will come down, let's just say it's a locust, and they will smell the plant. So now we're dealing with olfaction, which is smell. That's the second thing. So we went from a visual, from a distance. We're now a little bit closer now. We have olfaction. Olfaction can be effective over a distance of several hundred feet or even several miles. But the olfaction is a little bit more of a close range type of thing. The visual system is more from a far range type of thing. And then once you get really, really close, now you're involved in gustation, which is taste. And the insect, once it sees it and it smells it, it now wants to taste it. And so if it's past the visual test and it's now past the olfactory test, it now has to pass the gustation test. It will take a bite of it and make sure that this is something that it wants to feed upon. So there's a sequence of events, the first one being electromagnetics. And thank you so much for me bringing into it because I really didn't think I was going to talk about it. But you made a mistake. You stepped in it. And so therefore I brought it up. And yes, we probably lost a lot of listeners, and we're all down to 3 right now. But we're going to do our best to keep those 3 listeners on the line.
Good. You did good. Keep it going.
All right. So that's where it goes. So first, you got to visually see what it can. Olfactory, you've got to smell it, and then you've got to be able to taste it. And if it passes those tests, and passing those tests is very different from what you and I would determine, let's say, a salad would be. So I'm not going to bring in greens because we're talking about locusts or we're talking about deer where we're all eating greens because we're omnivores. We eat meat, but we also eat plant food. So if we're eating that plant food, we are also going to look at it. We want to see lettuce that looks green, that doesn't have brown. We want to taste it. We want to make sure it has a little bit of flavor to it, although I have to admit lettuce doesn't have a lot of flavor. And so we want to be able to taste maybe other things in our hypothetical salad. We want to taste the carrots. We want to taste the cucumbers. We want to taste the tomatoes that are in our salad. And if it passes the taste test, we keep eating. If it doesn't pass the taste test, we stop eating. And this is the decision that deer make. And this is a decision that insects make. And so it's a very simple system. So I hope this didn't, burst the bubble or anything.
No, that was all
your
perfect.
Your friend is not too disappointed. Okay, good.
This is actually the part of the information that made me, one of the metrics that made me realize that when I transitioned from a completely degraded farm like everybody else, to I call it farming in nature's image or biomimicry or whether you want to call it regenerative or soil health, whatever. Just thinking differently is I heard you talking about this and I thought, I don't want to be a wiener. And Rick Haney is the one who first said that. I think it was on this podcast, don't be a wiener. There were many colleagues of mine, or I guess maybe competitors, I don't know, who said, no, a lot of people are very good at copying information and repeating it, right? And if that weren't the case, there would not be a need for intellectual IP lawyers, right? There would be no such thing as patents and trademarks. Americans or human beings love stealing shit, period. And that includes intellectual knowledge. I've had it happen. But one of the first, this information made me go, oh my gosh, I have got to get rid of insecticides immediately. And I remember years ago, I had a monoculture forage soybean field, and I got beetles. And I said to my neighbor farmer, who obviously conventional farmer, chemical farmer, oh my God, what do I do? He said, no worries, I'm ahead of you. It hit our threshold too. We're going to be flying overhead. I did a really cool video for YouTube, I think it was, called Death from Above. We're going to fly over my farm and drop, I'm going to say Mustang Max if my memory serves me. I don't know. I may have made that up. Some type of insecticide, and just nuke the snot of everything in this field. No more insects. It's going to be pretty green. I'm growing big antlers for deer, right? And we did it, and I was excited. And I said, no more of that. Period. Out. And neonics, obviously, out. So that knowledge, that information blew my mind. But getting back to this whole, so what are they using certain antenna? How, and then are there ways that, I guess this can also lead into the bricks conversation. Are there ways that we can look at other than bricks? Are there tools, any apps or satellite imagery of plants or fields or whatever that we can use that puts us on that insect level? You like how I did that? We now have to go up to that insect level.
That was very, very smooth. Yeah. You've got skills, Jason. I think you missed your calling. Yeah. All right. Is there anything you could do? Yeah, there are a lot of things that you could do. There are probably over 100 different ways, and you can order test plants, maybe 1,000 different ways if we get to the nitty-gritty of biochemistry and taking a look at why plants grow and how everything moves around a plant and what type of nutrients it does. So we can measure all of that stuff. All of that stuff can be measured. But when you are measuring that, what you're doing is imagine a circle, and imagine all of these tests on a circle. All of these tests on the circle will give you a more complete idea. So if you want to test, let's just use a number. Let's just use 100, okay? If you have 100 tests that you are going to use in order to test your plant, you are getting a more and more complete picture as to how healthy that plant is, because you are filling the circle up little by little, and as you add each additional test, it gets to the point where you know a lot about a particular plant. What bricks is in the center of the circle. Everything associates and supports bricks. Bricks is the key. It's the first thing that needs to be done, and then if you have deep pockets, you can test with 100 different experiments about all of the details and all the nutrients to your little heart's desire that you want to know about your particular plant. But it all starts with a bricks reading, because this is, in essence, all it does is it measures plant health. And when you have that, and there's actually a lot more to it now that I've learned, that I've talked about in the YouTube videos, and so anyone who wants to go there, they can take a look, and they want to do a deep dive, they can. But what it does is it gives you that baseline saying, aha, this plant is healthy, or aha, this plant is unhealthy, or if you want to go even further, and I do, is, oh, this plant is unhealthy, but exactly how unhealthy is it? Or, yeah, this plant is pretty healthy, but exactly how healthy is it? Can I put a number on this? Because as a scientist, you want to put numbers on anything. You want to test something. You want a nice, clean digital readout. You want to be able to get that nice, clean number so that you can compare two plants against one another. This is how science works. We work on data. And so that's where all of this kind of begins with, is that there are lots of other tests you can do. But once I realized that you need to start with bricks, and then if you want to know the details, you can now start consulting other tests, such as the Haney test. So I just mentioned that because you brought up Rick Haney. Mm-hmm. But Rick Haney has got a powerful soil test. It doesn't tell you everything that you need to know, but it is very complete about telling you how healthy the soil is, which then is a reflection upon how healthy the plant is that is raised in that particular soil. So once Rick Haney has got his Haney test, he kind of has an idea of how healthy the soil is. We can now test the plant and say, yes, this is working, or no, it's not working. And everything is now fine-tuned when you run one test against another, such as a Brix test against a Haney test, which, as some of our listeners may or may not be aware, is a specialty soil type test.
Yeah. So Brix. Let's just jump into Brix.
All right.
BRIX. Right. And I'm sitting
That's
here.
Correct.
I'm sitting here with my refractometer. I've got the model BTX1. I could be convinced to get a new one or a different one.
Is it digital, or is it the one that doesn't take batteries?
It is not digital, unfortunately. I'm
Okay.
open to hearing about a better unit. I'm sure our listeners are as well. But I remember years ago I was giving them out to some of my more advanced clients, and they were looking at them like, "What the hell is this? What am I going to do with this?" And I've seen the folks. I have bees. I've seen the beekeepers use them in the wineries, etc.
Oh yeah.
All right, talk a little bit about what BRIX is with the refractometer that you use to measure Brix, and then what kind of bring us into the number thing, so it all contextually.
I'll be happy to bring you in. Yeah. We need to start with the guy who did it. Dr. Brix is the guy who did it. It simply was just named after him. So in case someone's wondering, why did they come up with such a stupid name? It's like, well, it was the guy's name. So Dr. Brix came up with it. It was named after him, and he found out that light bends under certain circumstances, and that is if you put a liquid, any type of liquid, and you want to test a certain parameter on that liquid, such as the bending of light, thus a refractometer, because it's measuring refracted light, which is bent light, then that could be possibly useful. And so it did turn out to be very useful. So when Dr. Brix came up with it, it is now known as a Brix refractometer. It can be used, it's used steadily. I mean, it is so commonly used in the wine industry, in viticulture. It is so commonly used down here in Florida and in California too. Consultants, when they have their orange groves, especially as they're getting to that point where they're ready to pick, will have one in their back pocket, because they need to know exactly what the orange is at. They need to know exactly what the grape is at before they pick it. They need to know exactly the quality of the beer. It's used in the beer industry. This is kind of how it began originally. So there are certain fields that use it as a matter of routine. It is a relatively new concept. When I say relatively new, it's only a few decades old, because it's only been around since 70s and 80s or so, and that's when it kind of began, even though Brix was known long, long before that. But once we moved into the 70s and the 80s, it was Kerry Reams and some others who actually started testing other things besides beer, besides oranges, and besides grapes, which is still being done today. But what they started looking at was the leaves. It was untraditional. It's not something that you think of doing, but they wanted to test leaves, and they found out that if you squeeze the juice out of a leaf, it doesn't matter what that leaf is, whether it's a flower, shrub, or tree. If you squeeze out the juice, you're going to get a few drops. Usually you need more than one leaf, I should tell you in advance. Many people have tried one leaf and they can't get it.
I was going to say, I'll just save people a lot of time and frustration. You need a bunch of leaves. Yeah.
You need a bunch of leaves. So you're going to need, depending upon the size of the leaf, it's tough to do this less than 5. Yeah. I've done as many as 30 in a single shot before. So it depends upon the size of the leaf. If you're dealing with an elephant leaf, you're dealing with a corn leaf. These are obviously big leaves that you can get by with one or just part of a leaf.
So I went out.
Will do just fine.
I went out it's probably been a week now, and I take Rick and I have the soil talker, so I take respiration data pretty much all the time. I'm a dork, and I also carry in my same bag. I carry my refractometer. And I plucked a bunch of the neighbor's neonic wrapped soybean, leaves, and I crush them up in my hands and squeeze that out. Can you talk about the process and what plants you look at as it relates to agriculture?
Sure. What I use is, I use what the masters did back in the 70s and 80s. A lot of them just used a garlic press.
Yep.
It was there, it was available. So I started using a garlic press too. It takes its toll on your hands. So if you are doing a lot of readings, you will find that your ability to squeeze is much stronger the first time you do it, and it's not as strong by the time you get to the 10th or the 15th or the 20th squeeze. So because of that, I've kind of moved away from the garlic press. I still use the garlic press. I especially use it for fruit. If I'm testing fruit, whether it be an apple or an orange, I will use a garlic press. It's a lot easier to use that. But when you've got leaves that need to be squeezed, I have a plant press that I use. And this plant press is also fairly well known in the industry, but it's not as commonly known. Most of the listeners, the vast majority, 99% of the listeners right now, are not going to be going in this direction. But I do, because I've got a lot to do. If I go to a farmer's field, I may have to do 20, 30 or more readings, and I want to be able to get good, reliable readings. And so I have a plant sap press that involves, I kid you not, the same thing that you lift a car with. Yes, no joke. So that's how this whole thing, it's all kind of like handmade. Many people make them handmade.
Yep.
They're available in certain locations, and I use it in order to, with a handle, and I squeeze it just as I would if I was lifting a car, in a very similar way if you've seen them on the internet. And that's what I use in order to get the juice out of leaves, and a lot of them, because I'll put on easily 10 to 15 at a time and squash them in there and get plenty of juice, more than enough, because I only need 2 or 3 drops for the refractometer. I usually get more than enough, but sometimes I may need to test more than bricks. And so if I've got more equipment that I want to measure, if I want to measure the acidity, if I want to measure the pH and other things like that, I'm going to need more than just 2 or 3 drops, because once I use those 2 or 3 drops for the bricks refractometer, I'm going to have some left over. And so therefore it becomes important for me as a scientist, for one who likes to collect data, that I've got to have a little bit more than 2 to 3 drops, and that's partly why I use that. So those are the 2 instruments that we use in order to squeeze it. Now, for those farmers who are Herculean hands, and I think I may be talking to one right now, there are some farmers out there. I've shaken many farmers' hands before. I would have to say some of them have hands that look to be, give or take, about 2 to 3 times larger than my hand. I've never seen such big hands before in my life. And so these guys right now, they kind of just poo-poo me when I tell them, by the time you get to the 10th squeeze, you're going to start to get tired. And many of them have told me, I'll be fine. And I actually believe them because I've seen their hands.
Yeah, but hey, so they know nothing about electromagnetics and insects. So there's that.
That's right.
Just throwing that out there.
I got to make sure that my hands are still, able to type at, 50, 60, 70 words a minute. But they're out there fixing their John Deere equipment, and wow. Those fingers are bigger than my arms. So because of that, a garlic press will be good. The bad side of that is their hands are so strong, they're breaking them more often than I do.
I was going to say,
a garlic press is relatively cheap.
I heard a story
10, 15,
of
$20.
A guy used a garlic press, and I was it Pampered Chef or something. I can't remember the brand name, and his wife was so pissed because he broke it. And I had a friend of mine take vice grips. You can buy these now.
You can.
Somewhere.
Yeah.
He took vice grips and then a pipe and cut it and made us a really very handy tool to squeeze the sap out of the plant. So that's what I use.
A lot of the stuff is homemade right now, and it works just fine.
Yeah, and I'll post for those who are interested. I'll post a picture on the Facebook or somewhere on Instagram for everyone to look at that. But okay. So we're doing that. We're squeezing it out. We drop 2 or 3 drops on the prism, drop the flap down on the refractometer, and it what does it do? It says, hey, your plant sucks, or it says, hey, this plant is very good deer food. You're going to grow 200-inch whitetails.
Yeah, it's really interesting that you say that. You're right. It does tell you that it sucks. What it does is a voice appears on the refractometer. It's usually a female voice. People feel less intimidated by a female voice, and it will then tell you that you suck. You need to get out of farming, and you need to move on to some other field. Now,
so I'm going to call we just created something new. I'm going to call my IP lawyer and develop one that, based on whether it's let's say it's a 13 bricks, it's going to flash up like a 150-inch buck, and then if it's a 14 bricks, you hit the magical 200 mark, and if you get over that, then we're talking, pretty serious. So I'm going to develop that.
Okay, now once you start selling this, don't forget the small people who helped you get to where you are too, like me.
I'm pretty sure someone can scale it quicker than I can now that I just shared that idea.
I think they could. Now what you do is you look through the viewfinder. So for the one that doesn't have the battery, you look for the viewfinder, and you aim it roughly towards light. So it's not directly towards the sun, but you can put it in the direction of the sun. If you're inside, you can shine it, or you can look at it through any of the incandescent or fluorescent lights. You usually just need a light source. And then when you look through it, boom, you're going to see a line. And that line has got a number of gradings, and the gradings are 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to maybe 30 or so. And you look to see where that line is. And if the line is between 7 and 8, then you say, okay, my bricks is somewhere in the 7s. Let's just say it's at 7.5, and that's how you do it. So the reading can be done within a few seconds. It's very, very quick. So the digital one, and this is the shameless plug for that. I'm not selling or anything like that, but when you're a scientist like I am, you want to be able to move quickly from one to the next. The digital one doesn't have that little flap. You simply put it in the well, the 2 or 3 drops in the well. You push a button, you get a reading in about 1.5 seconds, and it's a digital reading too. So it comes up and it tells you 12.2, and wow. Man, what does that do to your ego, Jason? I mean, when you're a scientist and you see something, it's not just 12, but it's 12.2.
Yeah, now
it's totally irrelevant.
There's no question.
Farmers, I don't think. No, you don't need it. You don't need it at all. However, I need it because I'm a scientist, and I just get giddy when I see 12.2. So if you want those points, you have to get the digital one, and that's going to be able to do it. You're not going to be able to get much closer than about 0.5. Yeah. So you can get a 7.0, 7.5, 8.0. That's about as close as you can get with the refractometer that you have, the inferior model that you have now.
Yeah, the cheap model.
The digital one, though, the digital one, that is going to set you back a little bit. There are going to be, I've seen them running 140. Some of them can get to be $300, $400. So they're going to be more expensive. They do use batteries too.
Yeah, maybe you can email me or text me or whatever a couple of, not that you're selling any, but a couple units that you think would be good for a property owner in those various budgets. 1 or 2 models of the digital. Because honestly, I use nothing against VG, and I'm sure VG, maybe they have digital. I don't know. I bought mine years ago, and it's analog, and it worked for.
Mine's a VG. It's a VG digital model.
Okay.
Mine is a $300 model. It is VG. VG still sells their stuff. There are some less expensive ones, from what I can see, and from the comments that I've heard from people who bought them. They do just as good a job as the VGs.
Oh, that's good to know. Okay, very good.
Yeah, that is. I know that's not helping me, because if I was selling it right now, I'd have to say, yes, you definitely want the Tom Dykstra model.
Yeah, there you go. There you go.
Yes. Yeah. But I'm not selling it, therefore I don't have to say anything stupid like that and change my voice and take on a deep husky voice to pretend that I'm someone that I'm not.
Get to work. We'll delay the release of the show. Okay. So we're looking through it. And I'm going to let you just run with this because I know you're going to. Tell us what the hell we're looking at. I mean, what? All right, let's say we see a 2, a 3, a 5, a 6, an 8, a 12, whatever. And then what does that mean? What do the insects see in that?
Okay, well, first let me tell you what you're seeing. What you are seeing is a measurement of the amount of sugar in the plant. Now, what you are technically testing, if you're a scientist, and I don't want to lose anyone because I've only got 3 listeners right now, and I don't want to lose you 3. But for you 3 listeners right now, you want something that is going to give you enough information. And so we don't need to go too far on this, but it's essentially a refractometer, meaning it's the bending of light, and it will bend in any liquid you put on it. So for a technical reason, it's measuring the bending of light. For a practical reason, for you and me and our 3 listeners right now, it is measuring sugar. And because it's measuring sugar, it is, in essence, making an indirect measurement of photosynthesis. We've now got a means to test photosynthesis, a means to test how much photosynthesis is occurring. If a tree is healthy, it's going to be photosynthesizing a lot, which means it's going to make more sugar because that's the end product of photosynthesis. That's what all plants do. That's what they are here to do in no small part, is to photosynthesize sunlight and CO2, turn it into sugar, the end product, which then serves as a food source for microbes in the soil, serves as a food source for deer, serves as a food source for us, and it serves as a food source for insects as well. They need a certain amount of sugar as well.
So we're talking photosynthetic.
That's what, in essence, you're measuring.
So we're talking photosynthetic capacity. How about that?
Yes, that'll work. I can deal with that. So yeah, photosynthetic capacity, you're measuring how well the plant is photosynthesizing, its photosynthetic capacity, and therefore, and this should make sense, is that when you are dealing with a 14 brix plant, you can assume, rightly so, that you're getting more sugar produced, a higher capacity of photosynthesis than a plant that's coming in at 2 brix. That should be intuitive to anybody who's listening. You don't have to think too hard in order to come to that conclusion, and that's why, in no small part, this is the first test that needs to be taken. Because once you have a reading of how healthy your plants are, you can actually make a lot of conclusions just based upon that, and I have. And that's why if you wanted to go a deep dive, whether it be on this podcast or you wanted to go to the YouTube videos, you can do a deep dive and actually determine how far you want to go, because there are differences, legitimate differences between a 5 brix and, let's say, a 7 brix. There are some physiological biochemical changes that occur when you do that. There's a big difference between 10 brix and 13 brix. And there's even a difference between 12 brix and 13 or 14 brix. So we have all of these brix levels, and knowing what level you're at will give you a better idea of not only what insects are attacking, because certain insects only attack at certain levels of brix, and then once they get too low or too high, different insects will move in and, let's say, start attacking a plant. So certain insects will attack a plant at 3 to 5 brix. Different insects will attack a plant that's coming in at 9 or 10 brix. And so you start to learn these things over time, because if you're a dumb scientist like me, you've got way too much time on your hands and you're investigating this, and you realize, there are a number of conclusions to be drawn with these numbers, and that's why I came out and took the science to the next level, I think, and that is to say it's more than just about 12 brix. We've got reasons to get readings. It is beneficial in order to have readings to at least a 1 brix level, because there are a big difference between 7 and 8. However, I'm not too concerned about the difference between 7 and 7.5. That's about the minimum jump that you are going to see, but there are very many things that you can learn by using the brix refractometer. For example, the inputs. So if you're putting an input down, you mentioned the neonics, so let's go there. So if you take a brix reading, and let's say it comes in at 6.5, and then you spray a neonic, and then you go out and measure it again, and it's coming in at 5.9. Well, it just dropped. The plant just told you something. The plant just told you that it doesn't like the neonic. That's in part what it's telling you. This is a conclusion that you can draw. On the other hand, Jason has got this concoction that he makes in his garage. He thinks it's the greatest concoction since sliced bread. And he says, wow, I want to put this on a plant. I want to test it to see if the plant likes it. So he tests the plant. It comes in at 8.3 brix. He then puts out his concoction that he makes in his garage that he thinks is going to save the world, and it comes in at a 10.3 24 hours later. And Jason says, aha, I've now jumped up 2 bricks with this concoction that I made in my garage. That means the plant likes it. Maybe I can sell this and make a lot of money. And that's some of the beauty that you can learn when you're looking at bricks, is not only does it tell you the health, but it will also give you some feedback as to whether or not you're putting on something bad or whether or not you're putting on something good.
Yeah, and I was interested in some of the, when we managed, wildlife food plots or deer food plots, I was interested in some of the effects or impacts of inputs. So let's say synthetic N or NPK or whatever on bricks. And then I recently I've been trying to, which I'm honestly swinging and missing at right now, but I'm trying to find relationships between CO2 and bricks, and obviously rainfall and when the rain events come and how dry the soil is, and there's so many variables, right? The academician, to your example, right there.
There is a relationship between CO2. Yes.
That was going to be one of my questions. So go ahead and answer that.
Yeah, there is a strong relationship between CO2 and bricks, because the more CO2 you have, the higher the bricks levels. So this is known already. We have scientists have been studying for decades by raising the CO2 levels in a controlled situation, usually in a laboratory. And when they do that, they get faster plant growth, and you can get a healthier plant in a relatively short period of time by raising the CO2 levels up. This actually has great relevance to healthy plants, because what you will find is a healthy plant has a healthy microbial population in the soil. When this microbial population, most of the healthy stuff is aerobic bacteria, and so they are breathing aerobically, meaning they are breathing oxygen, and so they're taking in oxygen and they are expelling CO2. And some of the ppm levels, the parts per million levels around a plant or in the soil, can reach 500 parts per million, 1,000 parts per million, 2,000 parts per million. It's even been measured at 5,000 parts per million. When this CO2 escapes from the soil, from all this healthy bacteria, it is taken up by the plant, therefore increasing the health of the plant. So there actually is a relationship where one feeds the other. You scratch my back, I scratch yours, where oxygen is usually taken in. This can often be occurring with a high front, where pressure pushes the atmosphere into the soil as deep as it can. This oxygen then feeds the aerobic microbes. They breathe, they take a breath of fresh air. They then expel CO2, very similar to what you and I do, and then this CO2 is kind of trapped temporarily in the soil. Some of it escapes, it usually passes up to the soil, makes its way to the plant, from which it usually kind of started from, in a sense, and then the leaves suck in, through the stomata, this CO2, which is emanating from the microbes. So what you stepped in is that you actually stepped in a truth, whether or not you realized it or not, is that CO2 is very closely related to the health of the plant, and the plant will regulate that CO2 as far as it can. It wants to get the CO2 as high as it can in a very localized region around the plant because it benefits the plant itself. Is that the answer you were looking for, Jason,
That's
or no?
Beautiful. That's perfect. And actually, one thing I've learned there's a lot of stuff that Rick and I have learned with our soil talker, which is in essence a CO2. It's a robust CO2 sensor system, and by the way, it's patented. So if anybody tries to steal it, we're going to have to shoot them, because usually patents are very expensive to protect, as you know.
Now I know why you were shooting at me when I tried to break into your place. Got it. Thank you. This is making so much sense now.
So what you mentioned, 5,000 parts per million. We blow it up, sort of like somebody would look through a microscope at a slide or whatever. We blow it up, and one of our robust sensors, actually our entry level sensor, hits 10,000 parts per million as a max. And quite frankly,
does it?
If you're producing 10,000 parts per million CO2 in a soil, you're talking profitability, meaning inputs are
huge.
Pretty much gone. And this is how people are like, how are you growing all this stuff without fertilizer? And I get that out. And of course, very few people want to listen to the details underneath the soil. But I hit with my soils now, I can hit 10,000 parts per million in a matter of seconds, 4 or 5 seconds, and we're at 10,000 parts per million. So much so that at Gabe's. So we did it at Gabe's Ranch and then also at the Rome Ranch in Texas years ago. And Rick and I realized, okay, a sensor that can read over 10,000 parts per million is now necessary, and I think that is super cool. And we actually we have growers and researchers who use our more robust sensor that can obviously get much, much higher than 10,000 parts per million. So just throwing that out there. But I have definitely noticed, and these are data that I don't share really, kind of like the stuff you have, that there is a, how do I say this? So between my management and the neighbor's agricultural management, it's obvious it doesn't take a genius or the soil talker to say, okay, this is better for the soil health. Now he's trying to produce he's trying to produce junk food, in my opinion, or it's going to China or some other country, so it's useless he's not trying to feed the world, he's trying to feed his pocketbook. But right. I think, that to me, what I'm trying to look at now is how to weather what's the fluctuation, and that's one of my questions for you. If obviously when we take a soil sample, it's sort of a snapshot, right? Because look at CO2 respiration. Rick does his CO2 burst, so he dries it down and re-wets it. Bam, totally different. He always says that rainfall is fertility. That's true. When it rains,
rainfall is amazing.
Yeah, things grow. So how much variability would someone expect to see in their, let's say, food plot of whether it's a multi-species or soybeans or whatever, clover, based on weather, current weather conditions, time of day, time of year, et cetera?
Well, this is awesome that you bring it up. As a matter of fact, it's like a segue, even though you and I didn't plan this at all. And that is, when rain comes in, it's always a negative pressure that precedes it. And so when you have a negative pressure that precedes the rain, that means atmosphere in the soil around the rhizosphere is pulled up due to the negative pressure. So right before the rain hits, what happens? A massive amount of CO2 in the soil, which is kind of trapped in there temporarily, is now released because of the low front. So one, you get a boost of CO2. Two, you get rain. Rainwater is so much better than irrigated water. Three, as you probably know, there are actually nitrates, natural nitrates in the rain, which is caused by lightning too, and that's the third thing. So you've got, one, the low front, which brings up the CO2, very beneficial to the plant. Rainfall itself, much better than irrigated water. Now you've also got some natural nitrates, not a lot, but some too. And this rainwater causes a burst of growth that every one of us, you, me, everyone else, any farmer knows that the benefits of rain is nothing like simply just irrigating and putting out plain old good old-fashioned water, and they are not the same thing. So that's a great segue from what we just talked about with the CO2, and this is part of the reason why rain is considered to be so beneficial. It's not just a single component. That means water. There are actually multiple components of the rain that start even before the rain even hits the plant. So fantastic job. I know you weren't planning on it, but I'm just patting you on the back right now for a massive and awesome segue.
Yeah, that's the blind squirrel finding the nut right there.
Yes.
Okay, so when it comes to bricks, I've heard you and others say, mostly you, just to give everybody kind of an idea of what we're talking about, that the golf course, I'm not a golfer, so it's fun making fun of golf courses. The golf course is the classical, and you can correct me when I'm done with this, 2 or 3 or whatever. It's spoon-fed. It's a day away from death, and the agricultural crops seem to be in that 4 to 8, and then you mentioned this 12 that was all over the internet as kind of the rule of thumb. Everybody said, wow, if you get to 12, that's the holy grail. You don't have any pest insects. And then obviously above that, now you're, in the trophy zone. What is that accurate? And can you kind of talk, so people, when they get a 6 or an 8, should they just quit and pick up bowling or something?
No, 6 to 8 is actually pretty reasonable. So I've been impressed when I go out on the field thinking I'm going to be getting a low bricks level, and then I get a 6, 7, or 8. I usually get a little surprised. Is that healthy? No, it's not healthy, but it's just higher than I thought it was going to be because a lot of the crops that I have seen are usually in pretty bad shape. So we mentioned the golf course, and yes, I have talked about that, and there are other plants, household plants, usually that are away from the sun, very, very low bricks. They can get down to 2 bricks, 1 brick, sometimes below 1 bricks. And these are the type of plants that just don't do well, that if you actually, give them the opportunity to do their thing, they don't do well at all. And so for the golf course is what I mentioned, and every most of the golf courses are aware of this, is that if you are not feeding and watering the greens, I'm specifically talking about the greens now, not the rest of the golf course, which is usually much healthier, but the greens themselves do not have a very high bricks. They're not doing well. There's very little photosynthesizing part of the plant. And because of that, it needs to be fed pretty much every day. In some cases, they do it twice a day. But they're trying to keep the greens at a very high level. In order to do that, it needs to be spoon-fed. So when you mention, should I just quit my job and go do something else, when you're dealing with crop at 1 or 2, yeah, there's a certain amount of truth to that. I would say, yeah, you're not doing it. You're not doing it at all. It's time to move on. But most of the crops are usually between 3 to 7. They do have a fighting chance at doing a pretty good job of looking like it should be. It looks like it's doing what it should be doing. You look at it, it seems to be growing. It's putting out leaves. If you dig it up, you see it's putting out roots. So therefore, at a very superficial level, everything looks fine. But it's not fine because we start testing it, not just with bricks, but anything else that you want, and you realize, okay, there are some problems. You'd be able to find it out with the Haney test. We can find it out with the bricks, and you can also do various other tests and see, okay, we have some deficiencies here. Something needs to be done. And so that's mostly what I'm dealing with when we're dealing with the crops that we're looking at. Once you move into much higher levels, especially above 8, you've got a substantial amount of insect resistance that is occurring. You also get a substantial amount of water retention, too, where your water usage will drop by 20%, 40%, 60% or more based upon where you are at this point. There's several reasons for that. I'm not going to talk about the details of it because I don't want to lose our three listeners. But we're at that point right now where things are starting to get really, really healthy. Once you get up to 12 and 13, all you're going to do is get insects that are nibbling. Many people don't realize that insects will attack a plant. They will move in, they'll start to chew it, bite it, masticate it, realize that this is not something that's going to give them long-range health, and they're going to move on.
That's exactly what I did. Last night, my family wanted to go get Japanese food, and that's exactly my experience. As soon as I began masticating it, I looked around and said, "Hey, you guys want this? This is not a salad. This is not steak. I don't know where they got that steak, but it was just not good."
Yeah, this is a serious problem, especially if one of our 3 listeners right now is Japanese and taking offense at this, because this is obviously the greatest thing that you could do nowadays is to offend someone. So,
right.
If there is, someone out there, we do need to formally apologize to you. This is not anything against that at all. But I know exactly what you're talking about. You taste it, and you realize this is not worth eating. It's time to move on. I don't know what you're going to go get. Go get a pizza. I'm not showing favoritism to Italians right now. I'm just trying to make a point. Is that your taste buds will tell you, and that's the thing about our taste buds too. I'm sorry, I'm moving in vertebrates right now, but we love fatty foods and sugary foods. Why? Because that's where the nutrition is found, Jason. When we have sugary foods, that's where we find our water-soluble vitamins. Mm-hmm. When we have fat foods, that's where we find our fat-soluble vitamins. So we have a tendency to want fatty foods, especially if we're short some of these vitamins, like vitamin A and D. And when we want a sugary food, that's usually because we're short some of the water-soluble vitamins, vitamin C, among other things. And so this is just our body telling us that we want this food. Deer, it's going to be the same thing. They're going to want something which is relatively high because they know that if they're eating a leaf that's coming in at 14.4 bricks, that this is going to be healthy and it's going to give them the health that they need in order to, run away from the coyote or whatever animal might be going after them. So
feed me.
Or you. Yeah. I don't think it's going to be able to outrun a bullet. So my money's on you. My money's totally on you, Jason.
So what would
too much caffeine.
What would you say the weaknesses of bricks are? I mean, variability, and then is there a time? This may be proprietary. You may have to kill us. Or as Rick Haney always says to people, if you steal my ideas, I'm going to have to kill myself. Are there weaknesses to it? Is there variability? Is there a time of day we should test before a storm, after a storm, before rain, dry, whatever?
Yeah, the weaknesses of bricks have been talked about. They've been talked about face to face. They've been talked about in various articles, and I would have said 30 years ago I would have agreed with all of those problems dealing with bricks. Now, because you're talking to me later on, and it's now 2024, I have no idea when people are listening to this, if they're listening to it in the future, but in 2024, here I am sitting here thinking, wow, I've got an answer for pretty much everything. All of the problems that have been talked about with bricks, I have an answer for. And so because of this, I'm very, very comfortable using bricks, and I can now learn a lot more about the plant where I don't even need to use some of those higher level scientific tests, the ones that usually cost money. Because as you probably realize by now, bricks doesn't cost you anything. Mm-hmm. After you bought the refractometer, it's free. So it doesn't cost you a dime from thenceforth. And if you want to do 100 tests, it costs you $0. If you want to do 1,000 tests, it costs you $0. And so because of this, I would encourage people to pick this up because of a lot of all the things that you can learn. I've already told you about the inputs. You can test inputs too. If you have a healthy plant, for example, I can tell that because the variability throughout the day is going to run somewhere on the order of about 2 bricks. So if you've got a healthy plant, you're going to have, and it comes in at 14, it can easily go down to 12. That's really not going to be a big deal. And that's what kind of happens over the course of 24 hours. That doesn't mean the plant is losing health. That just means you've got some variability. On the other hand, you've also got the rain that we talked about. You brought that up before, so I can tell you've listened to some of the videos. And that is when rain comes in. And I'm just not talking rain. I'm talking major storm. I'm talking hurricane, something like that. When that comes in, the plants freak out. They pull all of the nutrients that they can, including the sugar, out of the leaves, and they send it down into the roots, and they just wait out the storm. So if the hurricane slices them off right at that root line or that soil line, they've got all those nutrients that they can now build back the plant. And so that's what the plant does. And so we have tested the bricks when a major rainstorm is coming in, major front, and it will drop. And it will literally get down to 1 or 2 bricks. And I'm looking at a plant that looks like it should be easily 7 bricks or more based upon what I think a plant should be looking at. But I'm getting readings of 1 to 2. And so that's because of the storm that's coming in. So yes, that happens. So these variabilities, this is not a problem with bricks. To a scientist like me, this is information. And information is what I thrive on. So when I see a high bricks, this gives me an idea of what's going on. If it gives me a low bricks, this also gives me an idea of what is going on. If I see the variability going too high, this gives me an idea of what is going on. If I'm putting on a particular input and it goes up or down, this gives me an idea of what is going on. So bricks, for me, has now become much more than simply, is the plant healthy or not? Now I've got to the point where I can actually take a look at the numbers and draw some conclusions where I'm still getting some useful information to the scientist, and I haven't spent any money yet. And this is the beauty. This is part of the reason why I talk about this to farmers or even, deer hunters, is that you've got the ability to test something for free, and if you can, take advantage of this.
Yeah, citizen
right
science.
Now, the economy sucks. Yeah.
Yeah, there's a lot that sucks right now, and the economy's right there at number 1. But citizen science, I like citizen science because you put it in the hands of the people, we the people, right?
Yeah.
And I don't like to have to rely on some academician at a state-funded school. So I love it too, and I'm excited to hear you back it so much, the refractometer. So I guess then.
Well, it's only because I'm way too familiar with it to the point where I've got nerd status. So you were talking about you being a nerd. I'm a nerd. This is probably why we're talking with one another. And the 3 people who are listening are also nerds. So it's essentially just a big nerd conversation.
Yeah. So I guess you would agree with me. I tend to piss a lot of my clients off, which is fun for me. I don't know why they keep coming back, but I will say things like if they're out in the field and they have, let's just say, hey, I'm not happy with this weed profile or this doesn't look good, I'll say, hey, throw a mirror down. And I always used to carry one with me, or still do sometimes. The last one I lost or broke or something. And I'll say, I found your problem. Look down here. They look in the mirror and they go, oh, you jackass, or whatever their choice words are. There's your problem. And it's funny, but in all seriousness, your farm is a reflection of you, and the management is all on you, right?
It is.
So oftentimes when someone will send me a picture of, I don't know, beetles or armyworms or whatever, I'll say, they're panicked. Oh my gosh, and it's very rarely is it a good situation. By the way, it's usually a monoculture GMO crop, tilled, sprayed, all that garbage. So it's usually not a multi-species biological primer cocktail that we promote. And they'll say, oh my God, look at all these insects. And I'll say, good, let them eat it. Because it's not deer food anyway, it's insect food, let them eat it. Am I being a jerk, or is that accurate?
You are both being a jerk, and then you're also being angelic by essentially telling them what they need to know. Because sometimes with some people, not always, sometimes you need to hit someone between the eyes in order to get their attention. Some will cry and run off, and they'll never speak to you again. Other people will go, wow, thanks, Jason, I needed that. And so you're trying to hit someone between the eyes, because if you get kind of measly and you're not really forceful about what you're saying, it's like maybe what we can do is we can try some things in order to help raise the bricks on your crop. Immediately, you are perceived as someone who doesn't quite know what they're talking about. And so, yes, you do have to hit someone between the eyes, and this is important. Most of the people that I talk to, not all, most of the people thank me for being tough with them, because we need to. I need to wake them up, usually because we haven't got a lot of time. And the time that I'm talking about is usually, let's say, if I'm dealing with a 60-year-old farmer, I'll say, look, there's a limited amount of time right now. I have no idea whether you're going to be around in 10 years, and if you are, you're still going to be farming, okay? So let's be honest. I need to hit you between the eyes now, because I haven't got a lot of patience to sit around for you to try something for 10 years and then realize, oh, it doesn't work. So to go back to your original question is, if you've got insects that are attacking, and it's specifically the insects that you mentioned, those are the insects that are attacking bricks that may be around the 9 or 10 level, I say, okay, there are ways we can handle this. We don't have to let the insects eat everything. We can actually attack it, and there are certain inputs that I can suggest in order to quickly raise the bricks within as little as 24 hours, so that you can get the insects off of your plants. They're no longer going to be interested in it, and they're either going to sit on your plant and just starve to death, or they're going to fall off your plant and go to another plant, or they're going to do any one of a number of things, or it can actually kill them on the spot. In the case of some sucking insects, you can kill them on the spot if you raise the sugar levels, if you raise the level of photosynthesis, and they're caught off guard. They can get a lethal dose of sugar, and that will kill them because it will dry out all of their cells, and they're usually dead within seconds.
Yeah, we charge more. We charge more money. We charge more money for that information, though, don't we?
Do you?
So that's all good stuff. I want to maybe this is crazy, but I thought about this morning when I actually prepared for this. Believe it or not.
No way.
Yeah, I thought maybe I could get Tom to wrap his mind to humor me for a minute and get away from the really super cool and interesting, fascinating bug world. I'm kind of with my eyebrows up, and come over to the vertebrate side, and specifically critter. The
dark side, yeah.
Yeah, a four-legged critter that has a four-chambered stomach and very complex herbivore. Maybe the deer, or so. Let's just pick the deer. So I struggle all the time over these diseases in deer. I personally think it's just a symptom of an underlying problem, and most of my peers get mad at me. And when they say, "Oh my God, are you suggesting chronic wasting disease, EHD, blue tongue? We should just take the hands-off approach," and I absolutely am, and I have been since I left college, because that's what makes the most sense. Not to mention, we have spent millions and millions and millions of dollars funding research to try to figure out things like CWD, and we have gotten exactly nowhere, period.
Yeah.
Except, what do they say? Publish or perish. Isn't that the saying in academics? They've added
That's notches. All you have to do.
Yeah.
Taking care of the problem is not going to help them. So yes, I know what you're saying.
So they've added notches to their belt or whatever, and they haven't solved the problem. And it quite frankly pisses me off, someone who genuinely loves all game and non-game, but especially whitetails and turkeys. So, like for example, EHD, epizootic hemorrhagic disease, and blue tongue. These are viruses that deer get through these vectors, these biting midges or flies. In the genus Colicoides. And I don't know if you've ever done any work with midges or flies or, no-see-ums or gnats or anything like that. The deer obviously get feverish. They're found in ponds and lakes and streams. And oftentimes it's in parts of, trophy zones in Iowa. And it's, sometimes it's the 160 or 80 or 200-inch buck that they want to kill. Have you done any work or can you deduce with me at least? And maybe this isn't scientific or quote unquote peer reviewed, which really doesn't mean anything anymore because those peers are sometimes bought off too.
Sometimes they came from the same laboratory. Yeah.
Yeah, exactly. Is there anything that supports my opinion in underlying functional ecology that they're always looking, oh, you know what, if we're going to get EHD and blue tongue, we need to shoot more deer. Let's shoot more does. And then all of a sudden, we're issuing more permits, more tags. But what comes to mind when you think about a white-tailed deer being weakened to a state that a gnat can introduce a virus that then results in its ultimate demise?
I can deduce the same thing that you probably deduced, that is probably deduced by the listeners right now, and that is a healthy individual does not get sick. We are fighting off cancer on a daily basis. We are being exposed to rhinoviruses on a daily basis. We're exposed to the flu viruses, plural, on a daily basis. Shoot, we're probably being exposed to the coronaviruses and all of the different forms that are out there on a daily basis, but we fight them off.
Yeah.
We mostly fight them off. And so we know that this was, these diseases attack the susceptible. So we usually mention the very young and the very old. This is very common. It's been talked about for a long time. However, we can also set ourselves up, too, by being unhealthy and therefore making us more susceptible. And if we are unhealthy, we are going to be more attractive to mosquitoes, colicoides, and some of the other insects that you're referring to. These insects, too, if they're generally not healthy enough, will also not be carrying disease. But if they're not that healthy, they are more likely to carry disease. We know from laboratory studies that most insects, we have some difficulty in infecting them with diseases. And this is because they do a pretty good job of fighting diseases off as well. Obviously, they don't want to die. But it is hard to get a 100% infection rate when we're dealing with insects in the laboratory. Now, if we do, then obviously we can get a very vulnerable strain, and we can do that. But the same thing is occurring out in nature. When we have an unhealthy insect, let's say it's whether a colicoides or a mosquito or something like that, it is more likely to hold on to disease because we do know that, for example, most of the Anopheles mosquitoes in the world do not carry malaria. Most of the Aedes mosquitoes in the world don't carry yellow fever or Zika. Most of them don't, but some do. It's a small amount, so therefore you can get bitten by hundreds of malaria mosquitoes, but if none of them have malaria, it's certainly not going to be transmitted. But if you do get just one and you are vulnerable, it is possible that you can get malaria. And of course, malaria is more common in some of the third world countries where health is not at a premium. It is a shame, but it is the way that it is right now. And so it is very unlikely that malaria can take hold and spread in a first world country. We do get it. There are cases of it happening, but generally it does not. So this goes back to what you were saying about the deer and about the sickness. If they are eating unhealthy food, they are going to be weakened. They are going to be more vulnerable to not only insect attack, those insects that will take a blood meal from a deer, but they're also going to be more susceptible to the viruses or bacteria that are sometimes, not all the time, but sometimes transmitted by these particular arthropods. And I say arthropods now because we might be dealing with mites and ticks, not just the insects.
So I guess you would agree with me that the massive, or that the what do I call that? the knee-jerk reaction of a state agency to say, you know what, it's been a rut, and usually it happens before you know it because seasons and framework and quotas are set before we know it. But some private land managers will say, oh, that's okay, you know, we're just going to harvest, you know, less or more or whatever the case may be. I personally think the idea of harvesting more or less, we'll stay with more does or deer because of an EHD outbreak is about as, it has about as much merit supporting it as going out there and shooting healthy people who had COVID but had no symptoms. Does that make much sense to you? I just think you're...
It makes perfect sense. This is what we're doing with the emerald ash borer, among others.
Yes.
Is we find, insects that attack a tree, and then we clear out all of the trees within a 50 to 100-foot radius of that tree. Same thing that you're talking about right now.
Yeah, it's asinine to me. It just blows my mind. And
I
generally, I couldn't say that around, quite frankly, I don't know if I have any colleagues who would... I mean, these are very smart people who are followed by more people than me on social media. And when they say that I'm crazy, that I should never be saying this, that I should be stripped of any and all certifications and they're free to take whatever they want, I personally think that's absolutely nuts. That this goes back to your comment that basically only unhealthy plants are attacked by these pest insects. And the same I don't care, it just so happens to be a 180-inch Iowa buck. I'm sorry, he was unhealthy. That's how nature works, right? I think you mentioned a gazelle or a cheetah or something earlier on. It would suck to be him, there's no doubt. But that's how nature works because someone else got a meal. And I think we're spending, these state agencies and land managers are spending entirely too little time saying, hey, wait a minute, what's the underlying cause of this? And I think we are more, when I say we need to eliminate toxins, we need to think about the agricultural system, and not to mention the 80,000+ chemicals that have been introduced since, World War II or whatever. We're ignoring the underlying cause, the functional cause of these, and we're hyper-focused on the symptoms. Unfortunately, those symptoms sometimes represent profit machines for some people, whether it's pharma, big food, or academics. I didn't mean to get on a soapbox there, but that's what I did. You did. You got up on the soapbox, but I'm only going to support you as you're up there. Doing a great job. So I'm just sitting here listening. Well, thank you. I was thinking about, and CWD falls right in line with it as well, but EHD, since it includes, so closely includes an insect, I wanted to deduce with a fellow scientist who's far smarter than me. We can deduce away, and we did. Very good. Well, hey, listen, we went an hour and a half. Honestly, I have a lot more bullet points, but I know you're busy. I don't want to keep you any longer. I think sometimes when you leave it in a situation where you could actually do a part 2 because there's so much more information out there, that's good. That keeps people hungry and thirsty. And I didn't even get into my citrus grove in South Florida. And I was going to pick on the University of Florida, talk about the Asian citrus psyllid and the leaf miners and and all this. This Yankee bought a 5-acre citrus grove on the Orange River. There's insect traps, stick traps all over the place, and my kids are going, well, geez, look at all the good insects you got on that glue. And, we feel like we're a voice in the wilderness. But I won't get into all that because it's all the same. It's all a focus on these symptoms and ignoring the underlying ecological dysfunction. You are correct. I mean, that right there is a recipe for a part 2 right there. So, if there was going to be a part 2, we could certainly move into that in many different realms, and that would be an enjoyable thing to talk about. So, good deal. So, you have me at hello. That sounds great. Hello. Well, Dr. Thomas Dykstra, awesome work. Congratulations. Thank you for being an innovator. Keep it up. I know the best is yet to come. I know you're working on some really cool stuff right now. So thank you. We are playing some games right now, yeah. Thank you so much for being on the podcast. We are honored to have spent, an hour and a half, I guess.
Happy to do so. Went really quick. I enjoyed myself, and I hope the listeners get something out of it. And as I said, if there's going to be a part 2, you let me know. We'll cover that at that time.
If there is a part 2, you would be an instrumental part of it.
Thank you, Jason. Bye-bye now.
Bye-bye. Wow, I hope everybody enjoyed that podcast episode with Dr. Thomas Dykstra, independent scientist, Dykstra Laboratories from Gainesville, Florida, as much as I did. I always enjoy talking to Dr. Dykstra. He just has such a wealth of knowledge, and again, his information, content, and work were instrumental in the way that I transitioned and decided not to be a wiener, but to jump right off the deep end and pop the cork and get rid of the sides and obviously focus on toxin-free management. So I want to thank him for that. I hope you guys enjoyed that. I'm going to go ahead. Some of the things we talked about, the refractometer, again, VG is where I bought from. Sounds like Tom also has his digital reading refractometer from VG. It's VEEGEE. I've got the BTX1. Again, nothing wrong with that. I want to say it was maybe $100 many, many years ago. I personally would probably get the digital if I were you. In fact, I don't have one, but I'm going to get one. I'm going to post some of these things, pictures on the Drop-Tine Podcast Facebook and Instagram pages if you want to take a look. And of course, I always love getting feedback, Jason at droptinepodcast.com. Thanks for listening.